That are few myriad
But for
Good evening, students. Just check out whether you are able to see the screen and audio is clear. One of you type yes message in the chat box. If the video, whatever the document I have shared, okay. Is it clear? Okay. Yes, Vedavati. Okay. So we will continue now. So pay attention. So in the last class, we had discussed about LPP. Okay, we had discussed the few questions on LPP, and in the first class we had discussed the 1 mark question on LPP, that is the definitions, and in the last class we discussed a 6 mark question. Okay, so 6 marks non-verbal questions we had discussed. Okay, so sometimes maximum 90% of the times the verbal problem only means non-verbal problems have been asked where the objective function and the inequalities are directly given. ಬಟ್ ಸ್ವಲ್ಪ ಎಕ್ಸಾಮ್ಸ್ ನಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ವರ್ಬಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ವರ್ಬಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಲ್ಲಿ ಸೇಮ್ ಥಿಂಗ್ ಯು ನೀಡ್ ಟು ಫಾಲೋ ದ ಪ್ರೊಸೀಜರ್ ಇಸ್ ಸೇಮ್ ಹಿಯರ್. ಓಕೆ, ದ ಪ್ರೊಸೀಜರ್ ಇಸ್ ಸೇಮ್. ಓಕೆ, ಬಟ್ ಹಿಯರ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಡೂ ಇಸ್, ಓಕೆ, ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ okay, so see same steps. Okay, the objective function will be given, z will be given, and then the constraints will be given to us. Okay, constraints will be given to us. So in case of this, what we will do, we will plot the constraints on the graph. Okay, and find out the solution region, and after finding out the solution region we find out the corner points. Okay, we find out the corner points. Okay, and then the last step we substitute these corner points in z and find out the minimum or maximum value. Okay, minimum or the maximum value of the given objective function. Okay, so this was the procedure we followed for the examples in the last class, to solve the examples in the last class. Okay, so today too we are following the same procedure, but here I am not explaining you the complete solution. Okay, because already you know now how to solve the solutions, these steps. You are familiar with these steps and you can solve the examples based on this. But here only we are discussing how to find out the objective function and the constraints. Okay, so these two things were already given to you in these questions. See, in the previous question already the z value, okay, and constraints were given to you. So see, in this question minimize. Okay, so in this question, see, you can see minimize and maximize. So z is already given. Okay, z is already given. Constraints are also already given. So z is given to us. Okay, constraints are given to us, and by making use of the constraints we are finding the maximum and minimum value. Okay, but now in case of verbal problems we need to find out what is z. Okay, and we need to write down the equation, that is the constraints. Okay, we need to write down the constraints. Okay, so here in case of verbal problems, understanding of the question, you need to read the question 2 to 3 times. Okay, and you need to identify what we need to calculate. Okay, what are your x and y values. Okay, and by combining this x and y value you need to write down the equation for z. Okay, we need to write down the equation for z. Okay, so 2 to 3 questions based on verbal problems also we will check it out. So maximum time a normal non-verbal problem has been asked. Okay, but few times they ask the verbal problem also. So you need to be ready with both the types. Okay, you need to be ready with the both the types of the examples. Okay, okay, ಗೊತ್ತಾಗತೈತಿ. Okay, so we will discuss now the verbal problems. Okay, see, pay attention. Okay, so this is the first verbal problem we are discussing. We'll be discussing. Okay, so it's in the second exercise of LPP. Okay, and after completing these two problems we will start with 3D chapter. Okay, so see, Reshma, this is the given question here. Okay, Reshma, so first we will read the question and see in the question each and every information will be given. Just you need to identify first what we need to consider x and y. Once we identify what are the variables x and y, okay, you can easily write down the constraints and the required equations. Okay, required equations you can easily write down. Okay, so say here the question is Reshma wishes to mix two types of food, P and Q, in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Okay, and food P costs rupees 60 per kg. Okay, the food P costs rupees 60 per kg is given to us. Okay, next in the second part of the question, they are stating, see, so this is the information regarding food P. Okay, and food Q costs rupees 80. Food P contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, while food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Determine the minimum cost of the mixture. Okay, we need to determine the minimum cost of the mixture. Okay, so we here the objective function. The objective function is, it must be a equation which is relating to the minimum cost. Okay, so now cost, see, whatever the cost is there, the cost is given per kg. Okay, per kg. So here our consideration, okay, the consideration is very important. Okay, what must be x and what must be y. Okay, so once again we will read the question. See, try to understand this. Reshma wishes to mix two types of food, P and Q, in such a way that the vitamin, see, the vitamin contents of the mixture contains at least 8 units of vitamin A. Okay, so it is consisting of vitamin A and 11 units of vitamin B. Okay, 11 units of vitamin B it is consisting of. Okay, so this information is given. So vitamin A and vitamin B ಎಷ್ಟು ಬೇಕಾಗಬಹುದು ಮಿಕ್ಸ್ಚರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋ ಸಲುವಾಗಿ. ಸೊ ಆದ ಕೊಟ್ಟಿದೆ. ಆಮೇಲೆ ಕಾಸ್ಟ್ ಇಸ್ ಗಿವನ್, and then they are saying the food P contains 3 units and then 5 units of vitamin B, and then while food Q contains 4 units and 2 units of vitamin B. Okay, so here we need to determine the minimum cost. Okay, so one ಅಥವಾ ಎರಡು ಸಲ question you need to read it clearly. ಆಮೇಲೆ what is x and what is y. Okay, that is very important. So the first step in the solution what we are doing here is, okay, so in the first step in the solution, see, we are considering, let the mixture contains x kg of a food P and y kg of food Q. Okay, so we are considering x kg of food P and y kg of what, food Q. Okay, so whenever we are considering some items in kg, okay, so for physical appearance it must be greater than 0. Okay, whatever the food length, height, all these quantities are there, they can't be below 0. Okay, so here what we have to do, we have to consider x is greater than equal to 0 and y is also greater than equal to 0. Okay, so food P, we are considering the amount of food P what we are considering is x kg, and the amount of food Q present in the mixture we are considering it as y kg. Okay, so now based on this, just off your mics, students. Okay, so see, pay attention further. Okay, so here what we are doing is, we have considered x kg of food P and y kg of what, food Q. Okay, now see, this food P and food Q is present in the mixture A. Okay, now food P is also consisting of vitamin A and vitamin B, and food Q is also consisting of vitamin A and vitamin B. Okay, so see, further we can draw a table based on the information. So see, this table is very important here. Okay, so see, food P, okay, it is consisting of vitamin A and also it is consisting of what, vitamin B. Similarly, food Q is also consisting of vitamin A and vitamin B, and also the cost of one packet of food P and the cost of one packet of food Q is also given, and whatever the vitamin A content is there, the requirement is 8 units, and here the requirement is what? 11 units. So it can't exceed 8, and here it can't exceed what? 11. Okay, vitamin B. Okay, now to design the equation, see, first we require a cost equation. Okay, so for cost equation, what we can do here, see, pay attention here. Just to find out the cost, see, food P, we have considered x kgs, and 1 kg is costing 60 rupees. Okay, so cost of the food P will be 60 into x. Okay, it will be 60 into x. Similarly, the cost of food Q will be 80 into y. In the cost 80 into y, but we want the total cost. So the total cost, cost function will be z is equal to 60x plus what? 80y. Okay, 60x plus 80y, because in the question they have asked, we need to calculate the minimum cost. Okay, we need to calculate the minimum cost. So here our objective function is a cost function, and this cost function can be represented as z is equal to 60x plus 80y. Okay, so we have first found out the what objective function. Now after finding out the objective function, next see here what we are doing is we need to find out the constraints. Okay, so to write down the constraints, we are combining these. Okay, vitamin A. Okay, vitamin A will be one constraint, and vitamin B will be the next constraint. Okay, so say here we are multiplying 3 with x. Okay, 3x, and 4 with what? Y. And this vitamin A, that is 3 into x and 4 into y, must be at least 8. Okay, now see, whenever the word at least is occurring, okay, at least, okay, two words are there, you need to be careful in the question. So whenever at least is occurring, at least means we need to make use of greater than equal to symbol. Okay, and then at most. Okay, the next word is at most. At most means this is the maximum. So we need to make use of less than equal to symbol. So whenever at least word is occurring, so you can see here the in the question the word at least has occurred. Okay, so see, you can see here at least has occurred. So whenever the word at least will occur, you need to make use of greater than equal to. Okay, greater than equal to. And when at most will occur, we need to make use of less than equal to. Okay, so remember students, okay, these 2 points you will remember. Okay, at least and at most. Okay, then see, based on this, now 3 into x and 4 into y, will form a equation, and this must be greater than equal to 8. So our first constraint, the first constraint what we will get is 3x plus what? 3x plus 4y greater than equal to 8. Similarly, based on this condition here, 5 and 2, 5 you need to multiply with x, and 2 you need to multiply with y. Okay, and then see there the total is less than equal to, it is less than equal to what? The total maximum availability is what? 11. Okay, requirement is 11, so it will be greater than equal to 11. Okay, it will be greater than equal to 11. And then we have considered the non-negative constraints x, y greater than equal to 0. Okay, so we need to write down the what LPP now to form the LPP. So further we need to check whether they have asked the minimum cost or maximum cost. So in the question they have asked the minimum cost. Okay, they have asked the minimum cost. So for minimum cost, what we need to do here is, for minimum cost, we need to find out the minimum value of this objective function. Okay, so rest of the procedure is same as we did in the previous examples, but writing down this table, okay, formation of this table, and writing the objective function and constraints. Okay, this is the important step. Okay, writing down the table and the this. Okay, so ಈ ಎರಡು step extra ಆಗ್ತವೆ ಇಲ್ಲಿ, consideration of x, y, the table, and then writing down the objective function and constraints. Rest of the steps you need to do it same. Okay, so one first example we have discussed. Now in the second example we will try to solve it together. Okay, we will try to solve it together. Okay, so here just the okay, graph is been given for okay, your help. So this, in this case, just I'll discuss the solution. So after plotting the inequalities, you will get the graph, and you can see the graph is what? Unbounded. So when it is unbounded region, okay, when it is a unbounded region, okay, you will get the corner points A, B, and C. So you need to substitute these corner points. Okay, and find out the minimum cost. Okay, we need to find out the minimum cost. So that part you all do it for homework. Okay, so only here I will be explaining you how to form the objective function and constraints. Okay, so you can take the you can plot the graph for homework. Okay, and check it with this graph. Next, similarly, we will discuss the question number 2 now. Okay, so in the question number 2, again we will try to understand this. Okay, so students, try to read the question once or twice along with me. Okay, so if you understand the question, okay, example is very easy. So this is the second question we are discussing for today's class. So see, a manufacturer produces nuts and bolts. Okay, it takes 1 hour of work on machine A, okay, and 3 hours on machine B to produce a package of nuts. Okay, to produce a package of nuts. Okay, package of nuts is being produced. Okay, next, it takes 3 hours on machine A and 1 hour on machine B to produce a package of bolt. Okay, so see, in last case also we have product P and product Q. Same, instead of product P and product Q, here we have package of nuts and what, package of bolts. Okay, next, he earns a profit of rupees 17.50 per package of nuts and rupees 7 per package of what, bolts. Okay, so whatever the profit he is earning, it's given here. Profit earned by selling one packet of nuts, okay, is 17.50, and similarly by selling the bolts, okay, is 7 rupees. Okay, so you have to understand, okay, nuts and bolts. Okay, instead of, now see further, how many packages of each should be produced each day so as to maximize its profit. Okay, so our function must be a profit function. It must be designed in terms of profit, and we need to find out the maximum profit. Okay, maximum profit. And to do this, they are saying if he operates his machines for at the most 12 hours a day. Okay, so see, they are making use of the word at the most. Okay, so machines, machine A and machine B can maximum be used, can maximum be used can maximum be used for what, 12 hours. Okay, can be used for what, 12 hours. Okay, so see, uh, solution I have already done for you, but we will try to see what must be the consideration of A and B. Students, those who are attending it live, what must be X and Y? Okay, what must be X and Y? Anybody in the chat box, you can type the answer. What we need to consider for X and what we need to consider for Y. Okay, what must be X value and what must be Y value based on this question. What must be X? Okay, machine A must be X, or machine B must be X, or package of nuts must be X, or package of bolts must be X. Okay, what must be X and what must be Y, you need to identify here. Once you identify that, rest of the question is very easy. Okay, so in the chat box you can read the question once again and try to reply what must be X and what must be Y value. Quickly reply it, so we will discuss the solution. Try to read it once again and try to tell me what must be X and Y. Anybody? So how to identify X and Y? We need to, I told you, what is asked, you need to check that first. Okay, how many packages of what each should be produced each day. Okay, so as to maximize his profit. Okay, so if I want to calculate the profit, okay, I require what packages are produced. Okay, what packages are produced. Okay, so here how many packages. Okay, so the question is for how many packages. Okay, so what I can do is, anybody who has answered in the chat box, X and Y, quickly. I have given you the hint now. The hint is the unknown things must be considered as X and Y. So see here, they have given a hint. How many packages of each should be produced each day? Okay. So what will be X and Y? Quickly, anybody? Bharat, Kirtana, anybody? Be quick. One of you can answer quickly. What must be X and Y? Yes, one of you have answered. Yes, Vedvati, nut, package of nut is X. Then what? One more package is of, another package is of what? Bolts. Okay. So package of nut will be X and package of bolts will be what? Y. Okay. So now see here in the question they have asked how many packages of each should be produced each day. Okay. So what I can do is I can consider the package of nuts as what? X. Okay. So the package of nuts, whatever the package of nuts is there, this thing we need to consider it as X. And similarly, package of bolts must be considered as what? Y. Okay. Now see, packages can't be less than 0, so x must be again greater than equal to 0, as well as y must be greater than equal to 0. Okay. So see, based on this question, pay attention now. So see, we will discuss the solution now. Okay. So once you are able to identify x and y, rest of the part is very easy. Okay. So see here in the solution we are considering, okay, let manufacturer produce what? X, okay, X package of nuts and Y package of what? Bolts. And therefore, X must be greater than equal to 0 and Y must be greater than equal to 0. Okay. So this is our non-negative constraints. Okay. So then the information can be tabulated as follows. So see, to produce nuts, we are making use of machine A and machine B. To produce bolts also, we are making use of machine A and machine B. Okay. So now to produce nuts, machine A is used for 1 hour. Okay, it's given in the question. Okay, to produce nuts, see in the first sentence they have given machine A. Okay, to produce a package of what? To produce package of, it takes 1 hour work on machine A and 3 hour work on what? Machine B. Okay, so it's already given. So based on that, we will write 1 and 3 for nuts. Similarly, for bolts, we will write 3 and 1. Okay, and both the machines A as well as B can be maximum used for what? 12 hours. They have also told the maximum usage can be done for what? 12 hours. At the most 12 hours. And while discussing the previous question, I told you when add the most is used, we need to make use of what? Less than equal to. So whatever the equation is there, it will be less than equal to 12. Okay. So see, first profit function. For profit function, profit on nuts is 17.50, profits on bolt is what? 7. So the profit ಹೆಂಗ್ find out ಮಾಡ್ತೀವಿ ನಾವು? A number of packets into profit on each packet. Okay, so 17.50 into x multiply ಮಾಡ್ತೀವಿ. So z value ಏನಾಗ್ತದೆ? 17.50 into x. Similarly 7 into y ಏನಾಗ್ತದೆ? Plus 7y. Okay, and this we need to maximize. Okay, now to write down the object, this constraint. So already we have written the objective function for profit. Next, for constraints, combine these two. Okay, combine 1 and 3. So 1 and 3 here. Yes, 1 and 3. So 1 you multiply by x, 3 you multiply by y, and it must be less than equal to 12. So we are getting the first constraint. Similarly 3 into x, okay, and then 1 into y, it will be less than equal to 12, and we already know x, y greater than equal to 0. Okay, and for most of the at most cases, it will be a bounded region. Okay, it will be a bounded region. Okay, and for at least cases, most of the time it will be a unbounded region, unbounded region. Just so you need to plot the graph. Okay, hope the example is clear. Okay, all of you understood how to do it? ತಿಳಿಯಾಕತೈತಿ? How to solve the verbal problems. Okay, so next we will again try to discuss one more last example, and then wind up the chapter LPP. Okay, so 1 mark question is occurring on definition, and 6 marks, a fixed 6 mark question is occurring. Maximum time non-verbal only are given, that is the first exercise. Examples are only given. Okay, so but 10% of the time there is chance of verbal also. Okay, so be ready with both the types of questions. Okay, next one more question we will discuss. Okay, and then start with this questions on 3D. We'll try to discuss the theory of 3D. Okay, so this is the question number 3. Okay, so here again you all read the question and try to tell me what must be the value of x and what must be the value of y. Okay, what must be the value of x and what must be the value of y. Okay, so again try to understand this value of x and value of y. Yes, value of x and value of y, question number 3. Okay, this is the question number 3. Number 3. Okay. So see, I will read it. A factory manufactures two types of screws, A and what? B. Each type of screw requires use of two machines, an automatic machine and a hand operated machine. It takes 4 minutes on the automatic and 6 minutes on the hand operated machines to manufacture a package of what? Screw A, while it takes 6 minutes on the automatic and 3 minutes on the hand operated machines to manufacture a package of what? A screw B. Each machine is available for at the most what? 4 hours on a day. Okay, the manufacturer can sell a package of screw at a profit of rupees 7 and screw B at a profit of what? Rupees 10, assuming that he can sell all the screws he manufactures. How many packages of each type should the factory produce in a day in order to maximize his profit? Okay, so again the question is for maximum profit. So what must be our x and y value? Anybody? Read the question once again and tell me what must be x, okay, and what must be y. So if we identify that, based on that we can write down, draw the table. Be quick, 1 minute I will give you. What must be x value and what must be y? What should we consider x and what should be considered y? Yes, be quick. Just type it. Yes, two of them you have replied. Vedvati, okay, screw A package, number of package of what? Screw A we can consider it as x and screw B we can consider it as what? Y. Okay, so x must be what? Screw. X must be screw package of what? Screws. Okay, package of screw A, and this must be package of what? Screw B. Okay, screw B. Okay, so now see, and whenever you are considering some packages, they will be obviously greater than equal to 0. Okay, this is the non-negative constraint, and because of this constraint, the solution region will occur in the first quadrant. It will occur in the first quadrant on the graph sheet. Okay, so now see what will be the equation. So we will try to first draw the table. So screw A. Okay, screw. Okay, yes, W A I will consider, and then yes, C W B. Okay, so screw A, screw B. So screw A I have considered x and screw B I have considered as what? Y. Okay, now see requirements. Okay, so requirements. Okay, to produce screw A, what we require? We require automatic machine. Okay, automatic machine is used and then hand operated machine is used. Okay, so two types of machines are used, okay, to produce this. Okay, one is hand operated and another one is what? Automatic. Okay, so by again reading the question, we can fill in the blanks here. We can fill the table. Okay, so we can do it here. Pay attention. We can fill the box here, required box. So whatever things are there. And then the last column, it will consisting of what? Availability. Okay, to what extent the things are available to us. Okay, so available. Okay, so now see, pay attention. Automatic machine. See, for to manufacture screw A, automatic machine we can use for what? 4 minutes, and hand operated we can use for 6 minutes. Okay, similarly screw B, to manufacture screw B. Okay, so manufacture screw B, we can use 6 minutes automatic machine, and we can make use of what? 3 minutes. Okay, so 3 minutes we can make use of what? Hand operated machine. Okay, so here we have 3. Okay, here we get it as 3. Okay, and then see the availability. The availability is maximum we can use the machine, both the machines, for how many minutes we can use it for 4 hours. Okay, so 4 hours we can convert it in terms of minutes. Okay, so 4 hours will be equal to what? 16 to 4, it will be equal to 240 minutes. So this will also be equal to what? 240 minutes. Okay, and then you can see the profit. Okay, so profit on one package of screw is what? Rupees 7, and on screw B the profit is what? 10. Okay, so next we need to design the write down the equations. Okay, so to write down the equations, what we can do, see, so based on this information, try to write down the equation quickly. Objective functions you try to write. Okay, as well as objective function, and then the constraints. What will be the objective function? You can type it in the chat box. Objective function, what will be the objective function? Okay, so I'll write it here. Just verify and sit with the book and pen. So you will find the class little interesting and you can understand what is being explained. Okay, so z is equal to, see, the objective function is a profit function, so it will be 7x plus what? 10y. So this will be the first equation, and we need to find out the maximum value, so we need to maximize this. Okay, next, the first constraint. See, the first constraint, we are considering it with respect to, okay, screw. Okay, so see, the first constraint will be 4 4x plus what? 6y. Okay, on will be on the automatic machine, and the number of minutes it is available is 240. So maximum it is available 240. And you can divide this, it will be 2x plus what? 3y less than equal to 120. Okay, this will be the first constraint. Similarly, the second constraint will be 6x plus what? 3y less than equal to 240. Okay, or on dividing by 3 we get 2x plus y less than equal to what? 80. Okay, so this is our first constraint and second constraint. Equation 2, inequality, and then this is third. Okay, so again we can solve it, so you know the procedure how to plot it on a graph. Okay, so graph part of these three examples you all tried for homework, and few more questions based on this you can solve it later. So we have covered all the questions. Okay, the important questions on LPP. So 1 mark question will be based on definitions. All the definitions we have covered, and another 6 mark question in the part T will be occurring on what? Will be occurring on LPP. Okay, solving this. Okay, so I request all the students to be perfect with this question. Okay, because sometimes integration question, how it is, the proper another 6 mark question is occurring from integration part. So example. Okay, the number of examples, minimum 20 examples you need to practice. Okay, if you want to solve the question on the properties. So instead of that, I find this example is better. Okay, in the party you can go with this example. Okay, so better ಈ example ಚಲೋ ರೀತಿಲಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ರಿ. ಒಂದ್ 2-3 ಸಲ you all practice it. Prepare ಮಾಡಿ practice ಮಾಡ್ರಿ LPP question. Okay, so next we will now begin with the next chapter, that is three-dimensional geometry. Okay, three-dimensional geometry. So the next part, so 3D. We will start with the questions on 3D. So directly we are first discussing the 3-mark question here. Okay, we will discuss the 3-mark question on 3D, a 5-mark question, and then we will discuss the 3-mark question in the next class. Okay, so first we will try to discuss a 3-mark question, a 5-mark question. Okay, so in 3D again, the number of the weightage is 9 marks. Okay, and 3D, and next we will be discussing vectors. So both the chapters are important from 2-mark and 3-mark point of view. Okay, so see, vectors. Okay, and then 3D. Okay, both I will be discussing. So see, in vectors you will get 1 mark 1 question, you will get 2 mark 1 question, and 3 mark 2 questions you will get. Okay, 3 mark 2 questions. Okay, so this will be 6 plus 2, 8, 9. Okay. So here we are getting how many marks? 9 marks. I think 2 mark, 2 questions you will get here. 2 mark, 2 questions, 6. Yes. So 2 marks. So altogether you will be getting 11 marks from vector topic. Okay. So from the vector topic you are getting 11 marks. Okay. And then from the 3D topic, okay, from the 3D geometry topic, you will get 1 mark, 1 question, 3 mark, 1 question. Okay. Nice. 3 mark, 1 question. And then we will get a 5 mark, 1 question. Okay. 5 mark, 1 question. Okay. So see, 1 mark 1, 3 mark 1, and 5 mark 1. Okay. So the 5 mark question, it's fixed every year. It's a theorem. Okay. You need to know some theorems. Okay. On lines and planes. Okay. Lines and planes. So on lines, there are 3 theorems. Okay. And on plane, okay, there are 3, but out of that 3, most of the time only 2 are occurring. Okay. So altogether, 5 theorems you need to know. So if you are perfect with all these 5 theorems, okay, you can easily attempt this. You can easily attempt this 5 mark question. Okay. You can easily attempt the 5 mark question. Easily you can attempt it. Okay. So 5 mark 1, 3 mark 1, and 1 mark 1 question. Okay. So see, all both together, both the chapters together, it will fetch you 20 marks. Okay. So in the next 2-3 classes, we will be trying to cover the questions on 3D as well as on vectors. Okay. And it's easy. Vectors at least is a formula based chapter, and 3D is also a formula based chapter. Easy to understand. Okay. So today's class we will be continuing. Okay. And we will be trying to cover this 5 mark theorems. Okay. So this chapter is divided into 2 parts, lines and what? Planes. Okay. So we have some theorems on lines and then some theorems on what? Planes. Okay. So we will begin with 3D chapter. Okay. So ಇಲ್ಲೇ 20 marks okay occur ಆಗತ್ತವೆ final paper ನಲ್ಲಿ vectors and 3D. Okay, vectors and 3D. See how you can prepare is, see, first we have covered matrices. Okay, and then we covered determinants. Okay, so we have covered questions on matrices and determinants. So matrices and determinants together you will fetch 20 marks. Okay, and then vectors and 3D together you will fetch another 20 marks. Okay, then we discussed LPP today in the last class. So here we are scoring 7 marks. So 20 plus 20 plus 7, it will be equal to 47. Okay, so 47 marks. Okay, and also we discussed inverse trigonometry. So inverse trigonometry in the previous class, it is helping us to score 6. Okay, so even if you are feeling maths as a difficult subject to score, okay, you can only focus on these chapters first. Okay, so if you focus on these chapters, ಈ chapters ನೀವು ಎರಡು ಅಥವಾ ಮೂರು ಸಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್, ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಸಿ you can score 20 20, and then this is 13. Okay, so 50 marks in these chapters. Okay, 50 marks are occurring in these chapters. Okay, alone will fetch you 16 marks. So 50 plus 76. Okay, 50 plus 76, it will be 50 plus 16, it will be equal to 66 marks. Okay, so 66 marks. Okay, so these chapters if you do, okay, differentiation and application of differentiation. So if you do these chapters, easily you can score 66 to 70 marks. 66 to 70 marks from these chapters. Okay, and then even relation and function chapter we have discussed. There 11 marks are occurring. Okay, plus 11. So it will be 77. So till now, up to the date, we have covered 60 marks. Okay. So in the next 4 classes, we will try to focus on vectors and what 3D, and then okay, now go with integration part. Okay, we will discuss integration. Okay, understanding the strategy, students. So prepare within a week. You can prepare these chapters and these 4 chapters easily. Okay, so within a week, if you prepare this, revise it 2 times. Okay, 60 marks are in your, so 60 marks preparation will be done. Okay. Okay. Yes. So we will begin with the first theorem. Yes. Okay. So the theorems on 3D. So slowly here already the proof also I have written. I will explain you the steps. Try to understand it. Okay. Try to understand. Okay. So the first question on three-dimensional geometry. The first theorem is equation of a line. Okay. Through a given point and parallel to a given vector. Okay. So understand the statement. So if the statement is clear, you can understand the figure, and once the figure and statement is clear, then the proof is very simple then. Okay, so see here we need to calculate the equation of the if I need to find the equation of the line passing through a given point and parallel to a given vector. Okay, and try to remember the statement because based on the statement only we are trying to remember the figure. Okay, so one at a time when you do, you will find it easy. But when all the theorems in the exam, any one will be asked. So try to understand the statement and figure properly. So there will be no confusion. Or some students confuse and without knowing the statement, they write some different proof for the given question. Okay, so that should not happen. So 5 theorems are there out of 5. Anyone will surely occur. In the part D of your question paper. So try to understand first one. Okay. So say the equation of the line through a given point. Okay. It is passing through a point and it is parallel to a given vector. Okay. So now see here in the figure, we have considered the line L. Okay. We have considered the line L. Okay. And see this line L, I'll consider it is passing through the point A. It is passing through the point A, and see it is parallel to the vector B. Okay, so almost see in the figure the two things whatever are given in the statement, based on that we have considered the figure. Okay, so see what we have done, we have considered A and we have considered B. Okay, so A is the point through which, this is the given point through which the line is passing, and the parallel vector is this vector B. Okay, so point A, so in the figure this is the point A, and the parallel vector is vector B. Okay, it is the vector B. So vector B and then the given point. Okay, so now based on this, let A be. Now once again we will try to understand this figure. So say the line L is given. So A we already know is the point on the line. So join this point to the origin. So whatever OA we are getting, okay, this OA, the vector OA, we are denoting it as A, small a. Okay, and it indicates the position vector. Okay, it indicates the position vector of the point A. Similarly, now see we are considering one more point P. Okay, and this P is a arbitrary point. What point it is? It is a arbitrary point. Arbitrary point meaning it is any other point on the line other than A. Okay, other than A, any other point is considered as what? A P. Okay, and then what we are doing is we are joining OP, and OP vector OP we are considering it as what? R. Okay, so try to understand. Now first point A. Okay, so A is a point on the line is passing through the point A. Its position vector is A. Okay, and P is any arbitrary point. Its position vector is what? R. Okay, and then we have a parallel vector, that is vector B. Okay, and now say always see, pay attention, if two lines are parallel, okay, or if two vectors are parallel, then we write one vector is a lambda times the other vector. Okay, so this condition we are using, vector A is equal to what? A lambda times the vector B. Okay, vector A is lambda times the vector B. So based on this given information, we can easily prove this. Okay. So see once again, see, pay attention here. Okay, so see here now, we hope the figure is clear to you. Once the figure is clear, the proof is also very easy. So see, a line L is passing through a given point, okay, and parallel to a what? A given vector, okay. So this parallel vector is vector B in the figure, okay. It is a vector B, and the given point is vector A, okay. So for the point A, the position vector is A, okay, and for the point P, the position vector is what? R, okay. Remember, so arbitrary points position vector is R, point A, the position vector is A. Try to understand this. So here OA is nothing but the position vector, and similarly OP. So this OA we are denoting by A, and OP we are denoting it by R, okay. And then we have the vector B. And then we discussed the condition between two lines, okay. So if two vectors are parallel, if vector X and vector Y are parallel, then vector X, I can write it as what? Lambda times vector Y. So if we write lambda times constant into other vector, then we can say vector X and vector Y are what? Parallel vectors, okay. Are parallel vectors, okay. So using this condition, now we will discuss the proof. So figure, for the proof, the figure is very important. Without figure, if you try to write the proof, you don't get any marks, okay. So first you need to draw the figure, and then using the figure, we can prove the result. So here the first statement what we are doing is we are considering A be the what? Position vector. A be the position vector of the given point A with respect to the origin. So first sentence we are writing regarding A of the rectangular coordinate system. Next, similarly, let L be the line which passes through the point A and is parallel to the vector B. Okay. So first we considered the point A and its position vector, and then we are considering the line is passing through the point A and it is parallel to vector B. And this is the second statement, okay. And the second statement is as per the statement of the theorem, line and given vector. Next, the third we are considering it. Let R be the what? Let R be the position vector of any of an arbitrary point P on the line. Okay, so other than A, we are considering here one more point, that is point P, and the position vector of this point P is R. Okay, now what we are doing is we are joining AP. Okay, see, we are joining AP, join AP. Okay, so then AP, see what will be AP now? AP, you can see the line joining AP or the vector AP will be parallel to the vector B. Okay, will be parallel to the vector B. Okay, and just now we discussed if two vectors are parallel, then one vector will be lambda times the other vector. Okay, one vector will be lambda times the other vector. So using this condition in the proof, since the two vectors are parallel, we are using AP is equal to lambda times vector B. Okay, AP is equal to lambda times vector B. And always when we are in vectors, we make use of AP. So AP can be written as what? OP minus what? OA. Okay, so here we have considered AP is equal to what? OP minus OA. OP we know the position vector of OP is what? R, and OA we know the position vector is what? A. So R minus A. Okay, what it will be? R minus A. And AP, so see, this will be equal to what? Lambda B. So lambda B will be equal to R minus A. Or on simplifying, we can write R is equal to A plus lambda B. Okay, we can write it as A plus lambda b, and this is the equation of the line. Okay, R is equal to A plus lambda b. So here what we are doing, for each value of the parameter lambda, this equation gives the position vector of a point P on the line. Hence the vector equation of the line is given by, okay, vector equation of the line is given by, okay, it is given by R is equal to A plus what? A plus lambda b. Okay, so once you understand the vector, so two, we need to prove it in two ways. One is vector form, another one is what? A Cartesian form. So if you have understood vector form, a Cartesian form is very easy. Okay. So till here all I've understood, students. Have you understood vector form? If it is clear, if any step not understanding, you can just text. We will discuss it once again. So first theorem, if you understood rest of the 5 theorems, you will find it very easy. Okay. Yes. Okay. So see, pay attention now. So R will be equal to what? A plus lambda b. Now see, try to understand the, okay, after finding out the vector form, okay, obtaining the vector form, next we need to obtain the Cartesian form. So to obtain Cartesian form, we are making use of the vector form. We are making use of the vector form. So we are making some changes in the vector form and trying to get the Cartesian form. Okay. So for that, what we are doing here is, okay, see, pay attention. So equation 1 we have obtained R is equal to A plus what? Lambda b. So now based on this, we are trying to get the vector form. Okay. So to get the vector form, see, 1 minute, pay attention here. So R, see, R is the position vector of what? Of the point P. Okay. And A is the position vector of what? The point A. Okay. And then we have vector B. Okay. So here what I will do is, in Cartesian form, I will consider the coordinates of the point x, P as x, y, and what? Z. Okay. So these are the for what? Coordinates. Okay. Coordinates. So Cartesian coordinates, what I will do, I'll consider it as what? X, y, and z. Okay. X, y, and z. Similarly for the point A, see, for the point A, I'll consider it as x1, x1, y1, and what? Z1. Okay. And for this B vector, I'll consider it as A, B, C, and this I'll consider it as direction ratios, okay, of the vector. Okay. So this vector, if you want to write, okay, in Cartesian form, it will be x I cap plus what? Y j cap plus what? Z k cap. Similarly, this vector A will be x1 I cap plus y 1 j cap plus z1 k cap, and vector B will be a I cap plus b j cap plus c k cap. Okay. So based on these values, now only we need to substitute this what? Cartesian form. Okay. Component Cartesian form of this vector in the result of what we have obtained. Okay. So for R is equal to a plus b, what we need to do, in place of x, we need to replace it by x I cap plus y j cap plus z k cap. Then vector A, you have to replace it by x1 I cap, y1 j cap, z1 k cap. And vector B, you have to replace it by its direction ratios. Okay. So based on this, see the further proof. The further proof is very simple. Okay. Try to understand it. So see the further part of the proof. Okay. So here what we are doing is, so see, R we are considering it as x I cap plus y j cap plus z k cap. A we are considering it as a1 I cap say x1 I cap, y1 j cap plus z1 k cap, and B we are considering it as a I cap, b j cap, and c k cap. Okay. So we need to substitute these values in the equation 1. See, in the equation 1 is R is equal to, okay, equation 1 is R is equal to what? R is equal to, okay, R is equal to, see the equation here, equation 1 is R is equal to A plus lambda B. So in case of A plus lambda B, we need to substitute this value, A plus lambda B. R is equal to A plus lambda B. So in this, see, R I have substituted, then I have substituted A plus lambda into what? Vector B. So what we are doing is, we are grouping the terms on the LHS. So it will be x1 plus lambda A I cap. So take I component common. So see, in the first term we have x1. In the second term it will be lambda into A, it will be lambda A. So it will be x1 plus lambda A. I cap is common, take I cap common. Okay, I cap common. Next, similarly, y1 plus what? It will be lambda B and j cap, and then z1 plus lambda C and k cap. Okay. So from this we get x is equal to x1 plus lambda A1, y is equal to y1 plus lambda b1, and z is equal to z1 plus lambda c. Okay, lambda c. So now what we are doing is, say, try to write down this equation 2, whatever equation 2 we have got, you try to write it in terms of what? Lambda. Okay. So see, here I will do it. So see, if I want to rewrite this, I can write it as, see, x minus x1 is equal to what, lambda a, okay, is equal to lambda a, or lambda will be equal to x minus x1 upon what, a, okay. So x will be equal to x minus x1 upon what, lambda a, okay. So based on this, how we can do it, see, as x minus x1 upon a, which is equal to what, lambda, which is equal to lambda. Similarly, see, here we can write y minus y1, okay, upon b is equal to lambda, and z minus z1 upon c is equal to lambda. So all these three values will be equal to what, lambda. So eliminating the parameter lambda from 2, we get x1 x minus x1 upon a, y minus y1 upon b is equal to what, z minus z1 upon c. It should be z minus z1 upon what, c, okay, z minus z1 upon c, okay. So this is the Cartesian equation of the line, okay, Cartesian equation of the line, in which form it is in Cartesian form, okay. So the first equation what we discussed was in what, vector form. So this is the vector form, r is equal to a plus lambda b, and based on this, we have obtained the Cartesian equation of the line, okay. So if the first theorem is clear, the second theorem is very easy. In the next 2 minutes we will discuss the second theorem also. So the theorems on two theorems on lines will get over, okay. And then we can discuss the theorems on planes in the next class, okay. So see, the next proof, it's almost similar. So understanding the figure is very important here. So figure ಮತ್ತು statement ಕರೆಕ್ಟ್ಲಿ ರೀತಿಯಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರಿ ಅಂದ್ರೆ ಈಸಿಲಿ ಪ್ರೂವ್ ಮಾಡಬಹುದು, okay. So see the second theorem, okay. The second theorem is equation of the line passing through two given points, okay. So the first theorem, it was passing through one point and one vector. Now here it is passing through what, two given points. It is passing through two given points. So the two given points, what I will do is, I will consider the two given points. This is the line, okay, and this line is passing through the two given points a and b. I will consider, okay, it is passing through a and b, and again I'll consider p as the arbitrary point, okay. So see, a is the position vector of the point a, b is the position vector of the point b, and r is the position vector of the arbitrary point p, okay. So see, same, let a b be the position vectors of the 2 points a and b respectively that are lying on the line. Similarly, let r be the position vector of arbitrary point p, x, y, z. Then p is a point on the line if and only if, okay, ap is equal to what, r minus a, okay. See, these 3 points are what, collinear, okay. So we are writing, okay, we are writing, see, ap is equal to r minus a, okay, and then we are, and ab is equal to what, b minus a, are collinear vectors, okay. So see, these all 3 points are collinear. We can see there from the figure, all the 3 points are collinear. So whatever the vectors we are obtaining, okay, along these points will be also what, collinear vectors, okay. They will be collinear vectors, and again the same condition for parallel vectors and collinear vectors we are using. That is, one vector is lambda times the other vector. So we are considering ap is lambda times ab, okay. What we are considering, vector ap is what, lambda times vector ab. So based on this, ap can be written as r minus a is equal to lambda into, again we get what, b minus a. So a you shifted to the LHS, so we get r is equal to a plus lambda b minus a, and this is nothing but the vector equation, okay. This is the vector equation. So now in this vector equation, what we need to do is same. To find it in Cartesian form, you have to substitute r in its component form, a in its component form, and then b minus a, and equate it to lambda, okay. See, the same steps what we did in the equation 1, we are doing it in the theorem 1. So see, same steps we are doing it, okay. So in the same way we can write down. So see, r is equal to, okay, r is equal to x1 xi cap yj cap zk cap, a equal to x1 j cap plus y1 z cap and z1 k cap, and b is equal to x2 y2 and z2. Okay, so substitute the values in place of r, a and lambda into, say, b minus a means we need to subtract the vectors component wise. Okay, subtract the vectors component wise. So it will be x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Next, equating the coefficients of I, j, k, we get x is equal to x1 plus lambda into x2 minus x1, y is equal to y1 plus lambda into y2 minus y1, and z will be equal to z1 plus lambda into z2 minus z1. And same way equation we can write here. Okay, we can write the equation for lambda. So this will be x minus x1 is equal to lambda into x2 minus what, x1. Okay, or lambda will be equal to x minus x1 upon x2 minus x1. So this is the first term we are getting. Similarly, we will get it for y and for z. Okay, and all the three are equal. So this equation 2 is also called as the equation of the line passing through 2 points in Cartesian. Okay, if your theorems are clear, examples will also be easy to solve. Okay, so today we will stop here. So two theorems we have discussed. Another three theorems are there that we will discuss in the next session. Okay. Take care. Bye.